Assalamualaikum. Welcome to my YouTube channel. I hope you are doing well.
Let's start our today's lecture. In the previous lecture, we discussed assignment number 1 in detail. I hope you understood that assignment. Now, in this lecture, we are going to discuss memory architecture, memory addressing, physical address calculation, and general addressing mode. Memory architecture. We are studying memory architecture x88. Before x88, x86 was very popular and commonly used, and it used 16-bit architecture with 64 kilobyte memory. How can we measure memory? The vertical dimension of memory gives the size of memory. So 64 kilobyte memory was used, which was divided into code segment, data segment, and stack segment. Code segment was designated for code or instructions, while data segment was designated for global variables, and stack segment was reserved for function calls and stack. Now we are studying memory architecture x88, which uses 1 MB memory, which is divided into 4 logical sections known as segments, which are code segment, data segment, extra segment, and stack segment. The purpose of code segment, data segment, and stack segment is same as x86 architecture, but now additionally there is another segment, that is extra segment, which is used for additional purposes. The x88 memory architecture uses 20-bit architecture, and to pursue this, we use a segment and offset pair. I hope you understood. Let's see what is a segment and offset. Segment is a contiguous block of memory often used in a segmented memory architecture. Means continuous block of memory which is used in segmented memory architecture. It means used in memory architectures that are divided into segments. And what are segments? Segments are just logical divisions of memory. What is offset? Offset is the distance from the beginning of a segment to a specific memory location. It indicates the position or displacement within the segment and is added to the base address of the segment to calculate the absolute memory address. In short, offset is just a distance from beginning of a segment to a specific memory location. We can say that IP serve as offset. Now let's see how to calculate physical address. In x86 systems, the physical address was of 16-bit as it was a 16-bit architecture, but we are studying x88 architecture which uses 20 bits, so physical address would be 20-bit. So how we achieve that? We use segment and offset pair in such a way that we add them. 16-bit offset is added to 16-bit segment, but to fulfill 20-bit physical address we need 5 nibbles. 1 nibble is equal to 4 bits. It means we have to add 5 nibbles into 5 nibbles. Moreover, if we add 16 bits into 16 bits, the result would be 32 bit. But we need 20-bit physical address. So what we do? We make the lower byte of its segment as 0, as 0 has no effect, and the upper byte of offset. When 16-bit segment is added to 16-bit offset, the result would be 32-bit. But we need answer in 20-bit. So what is done? We take 5 nibbles, in which 4 nibbles are of 16-bit segment, and the fifth nibble in the lower byte is 0. Then in 16-bit offset, we take upper byte of offset as 0, and 16-bit offset is used with them, making 5 nibbles. So these are added and 20-bit physical address is obtained. Now let's see an example. 1 triple D 0 is segment. Here 1 triple D is the value of segment, while 0 is the fifth byte which is 0. Then we have offset whose lower bytes are 0, 100 and upper byte is 0. Why we have done so? Because 0 has no effect. 0 into 0 it will return 0, and when we add 1 into 0 it will give 1. So it will not exceed the memory. So in this way 20-bit physical address is obtained. In 20-bit physical address we have 5 nibbles, while in segment and offset we have 4 nibbles equal to 16 bits. If we add 16-bit and 16-bit, the result would be 32-bit long in some cases. To prevent this situation we use segment and offset pair, so the address remains 20-bit long. I hope you understood. Then we have general addressing format. We will discuss different addressing formats in next lecture, but for physical address calculation we generally use the base plus index plus offset addressing format. Now let's see how to calculate physical address. We have to calculate effective address. What is effective address? It is final or calculated memory address which is used to access data or instructions, often resulted from adding the offset or displacement to a base address. Then we have to use formula for physical address calculation. Let's understand these steps with the help of an example. In example 1 we have given the base address, that is 0x0100. Then we have index. Source index is indicating index, that is 0x0200. Then we have the code segment whose value is 0x1000. For effective address we just have to add these values. So base plus index plus offset will give us 0x0800. We have to do hexadecimal addition. So by this we get 0x0800. Step 2 is physical address calculation. We have formula. We have to multiply segment with 0x10 and then we have to add effective address into it. So then we have 0x10A00. We can see here that the effective address is 16-bit while the physical address is of 20-bit. I hope you understood. Let's see the next example and explore new concepts. In this example, we are going to explore the concept of segment wraparound. Wraparound means when the value exceeds then the maximum limit of a segment. So it returns to the beginning of the segment, which is termed as segment wraparound. I hope you understood. So let's begin. Bx plus 0x7000 and offset is added to base. Okay, so base we have 0x9100 and we have the value of segment, that is data segment, which is 0x1500. For effective address we have to add base plus index plus offset, but in this example we don't have index, so it will be 0. So we can write as 0x0000 and base is 0x9100 and offset is 0x7000. So we will have 0x1000 in result of the addition, which is equal to, let's say, 17 bits. So here it exceeded the maximum limit of a segment. So what will happen? Segment wraparound will occur and we will have the result 0x0100. That one is considered as a carry and is ignored. So we will have 0x0100 as a result. Now we have calculated effective address and we can use it for calculating physical address. Physical address formula is segment into 0x10 plus effective address. So we will have 0x1500 as a result. I hope you understood the concept of segment wraparound. Let's consider another example which will reveal the concept of memory wraparound. We have base plus offset. The value of offset is 0x0100. Value of base is 0x0100. And the value of data segment is 0x triple F0. Firstly, let me introduce you the concept of memory wraparound. Memory wraparound means when the value exceeds then the maximum limit of memory. It is termed as memory wraparound. The maximum limit of a memory or physical address is 20 bit. So the answer must be in 20 bits. If it exceeds the limit, so memory wraparound occurs. So let's find the effective address. We added base plus index plus offset. In this example, we again don't have the index, so we put 0. Hence, we have in result as 0x0200, which is our effective address. Now let's calculate physical address. Data segment is being multiplied by 0x10 and is added with effective address, that is 0x0200, which results 0x100, which is 6 nibbles. Let's say these are 21 bits, so the result is exceeding the maximum limit, so memory wraparound will occur. The 1 will be considered as carry and will be ignored. So we will have 0x0000 as our physical address. I hope you understood the concept of segment wraparound and memory wraparound. Now let's consider memory addressing. In assembly language, instruction use memory addresses to access data. For this, they use different methods for addressing. We have direct addressing, in which operand is the actual memory address. Let's say an example. Example, move AX 1234. 1234 is a memory address, so its value is being moved to AX. Now we have register addressing. In register addressing, operand is the register. Let's say an example, add BX AX. The value of AX is added to value of BX. Then we have immediate addressing. Immediate addressing we have been using in our previous program. Immediate addressing means operand is a constant value. Let's see the example, move CX42. It means move the immediate value 42 into CX. Then we have indirect addressing, this type of addressing in which operand is a memory address which is stored in a register or a memory location. Let's see an example, move SIBX. Move the value stored in a memory address pointed to by BX into the register SI. It means BX is pointing to some address and the value stored at BX is being moved to SI. I hope you understood. We will explore addressing modes in the next lecture. I hope you all understood. Thank you.